All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to be continuing learning about ESP32 and Rust and doing embedded Rust programming for the ESP32. Um, Unfortunately, we are only going to be able to stream for like maybe 45 minutes today because I ended up starting the stream kind of late. It was a sort of mix of things. Believe it or not, um, I uploaded, uploaded, upgraded, updated. More of an upgrade. I upgraded from Windows 10 to Windows 11, not by choice. I mean, I had to choose it. I had to make that choice. But I I kind of had to do it because Windows didn't really give much of a choice. In that they basically decided to stop the security updates and probably other updates for Windows 10 as well. So I knew that eventually I'm going to have to switch to Windows 11, and I wanted to, put it off for as long as possible. Um, what was I saying? Yeah. So believe it or not, the upgrade, and I think this might have to do with my slow hard drive. The upgrade took a decent 8 hours, if not 12. I'm trying to probably 12. Probably 12. I think it was 12. Because okay, on this laptop, I also have Ubuntu installed. So I basically have dual boot going on. I can boot into Windows or Ubuntu, and Ubuntu is the primary one. So usually when I reboot the laptop, restart the laptop, or if it's off and I turn it back on, I'm presented with a bootloader menu. I believe it's the grub menu. Um, but I can't say for sure. It's a bootloader menu. I'll have to check exactly where it's coming from. It definitely only started becoming more prominent after I installed Ubuntu, after having Windows 10 installed already. So I'm guessing it's Grub. I'm not sure. Either way, doesn't matter. Um, Whenever I reboot the laptop, it boots into that menu, and in that menu there are maybe six options, five, six options. And at the top is Ubuntu. Then there's like one or two options more. I don't remember what they are. I think memtest might be one of those options, which makes me think that yeah, this might be uh uh the grub bootloader menu. um but yeah, also one of the options is the Windows boot manager. So if I want to boot into Windows, then I have to pick that option. If I just want to boot into Ubuntu, I don't touch the keyboard at all. And because Ubuntu is like selected by default and there's a timer running, so if I don't select anything or if I don't change the selection, it's just going to boot uh, into Ubuntu, which is great. That's kind of the behavior that I want because it makes it so whenever I'm in Windows, I can just reboot the laptop and then I don't have to touch anything, and it just boots into Ubuntu. This does present a problem though. Sometimes Windows updates, depending on what the update is, or even an upgrade for that matter, depending on what the update is, um, it might require one or more restarts, or one or more reboots, and then I get into that same situation of like the laptop restarts and it jumps into the grub menu, and so then I have to select Windows, because if I don't select Windows, it's gonna just pause the Windows update process which was going on, and it's gonna boot into Ubuntu. I'm glad that I'm glad that Windows is good about handling the update pausing process. So the next time that I try to boot into Windows, it's going to just continue that update process. So, anyways, I ran this update and it took When I say it took hours, I'm not exaggerating, dude. It took hours, but I now finally have Windows 11, and fortunately everything seems to be, for the most part, running well. I did have to reconfigure some things to make sure I'm launching the Windows terminal, not command prompt, because that thing for some reason got reset. And then I went to check the mic settings. I was expecting the volume to be messed up, but it was at exactly 94, which I don't even remember setting it at that. This might have been like back when I was doing VR chat live streams. I had to, I would often have to like change mic settings. And this was even before. This was like way. This was years before they had like proper mic volume settings. Yeah. This was like way before that. So, this is. I'm trying to remember when this was maybe 2020, maybe 2021, I think. I don't remember. Either way, I don't touch the mic volume settings from Windows audio settings anymore. And so I hadn't looked at that in a long time. And it happened to be set at 94, what I had left it at. I decided to crank it up to 100, and then when I came back into OBS, the volume was actually much higher, so I took it back down to 94. I'd completely forgotten that I had set that up, but yeah. Even in OBS now, the settings are exactly as they were. So far, um, given the very minimal use that I have of Windows, at least for the specific thing that I'm using Windows for right now, which is literally only streaming and also browsing. And well, the browsing is also very limited. The browsing is only during streaming, and also running my VTuber application, which is again only during streaming. So this is the very limited usage that I have of Windows right now. Literally everything else, I I've moved it over to Ubuntu. One last thing that I haven't moved yet, and that's not because it's not possible. It is very much possible. I just haven't managed to do it yet. I haven't gotten around to doing it yet. Is testing out video players. There are a bunch of open source video players, a bunch of very good open source video players. I wouldn't say that they're nearly as good as something like DaVinci Resolve, or anywhere even near Adobe Premiere, or whatever other whatever other video editing applications there are. I wouldn't say that it's anywhere close to that, but it is pretty decent. Like they provide you with a pretty decent set of tools. And if you are looking for very basic video editing capabilities, which usually involves a timeline in which you can set up multiple video tracks, multiple audio tracks. Maybe you can like split the video and audio and move the tracks around. Maybe you can like overlay stuff if you want, like create overlay text and all that. Um, if you want to do splitting of the video, if you want to create jump cuts in your video, very basic video editing stuff, nothing complex, nothing very flashy. These tools provide you these programs. These programs are basically they're basically suites of tools, suites of video editing tools. But yeah, these programs do provide you with that very basic set of video editing tools, and that's why I want to give that a try. Um, Something I want to try is using them on this laptop, this laptop that I'm currently streaming off of, on which I'm running Windows 11. I also have Ubuntu installed here. So what I want to do is install one of the video editing applications here and try doing the video editing here, because on this laptop actually has one of the best GPUs that I currently own out of all of my other hardware, because I don't have newer hardware. Um, all my hardware is usually older stuff. And I mean, it works great for me because, um, especially with the stuff that I'm doing, I'm able to benefit from all of this older hardware that I have. But in certain cases, I do kind of need better hardware. Like, a GPU could be beneficial. And on the Ubuntu side, I don't even need to worry about updating. This is kind of weird. On the Windows side, I've for years now I've had this issue where the GeForce or Nvidia or whatever, they have this a specific application. I forgot what the thing is called, but they usually recommend that you install that application and then do all of your stuff through that application. And there's a bunch of very interesting tools and interesting information and stuff provided through that app. But the problem is you have to log into that app. I kind of hate that, but you have to log into that application. I don't want the GPU update process to be so complicated. And for some reason, GPU updates on Windows have usually been a very rocky road for me. Um, they tend to sometimes cause problems. I remember I had one instance where I legit had to roll back the update to to a previous driver version because the one that was installed, it was causing system instability, and I wasn't the only one that was having this issue. So I like the fact that a lot of this is very frictionless on the Ubuntu side. Now, that's not to say that there isn't a chance that maybe an update could get downloaded, and an unstable update could get downloaded on the NVIDIA side. I need to make sure that the update process is not part of the system or the OS update process, because like we do like a sudo apt update and then sudo apt upgrade to do the update. I can check if it's not part of that, then that means that I have to do the update manually, which is actually a good thing. I should also look into what facilities they provide for rolling back a driver update. Yeah, I need to look into that as well, because there was a tool that I had installed other than NVIDIA. I think it's called SMI. I think so. Yeah, I think other than that, there was another tool that was specifically made for helping with um, driver installation. I can't remember exactly like what the specifics were around that. I'm gonna have to look into that again. Fortunately, Gemini has pretty decent information on this, and so Gemini walked me through this process. Dude, I feel like so many people are missing out on very how do I say this? So many people are missing out on workflow improvements by basically sleeping on LLMs because they are not using ele- elements because they are choosing not to use LLMs because oh, AI is evil. So they miss out on very valuable workflow improvements that they could have. I can't even tell you the amount of times Gemini has been helpful to me with troubleshooting stuff. That it is, dude, it is insane. And I'm just talking about like the Gemini web version. You also have the Gemini CLI version, which can, run on your, or well, it's not the model that's running on your machine. It can run commands on your machine, and so, with your permission, of course, it can run whatever specific CLI commands or bash commands or whatever is required in order to get whatever information it needs. And through that, it can set up this sort of agentic workflow where it can tell the agent, okay, do so and so thing, and your objective is to get so and so information. Once you've gotten the information, give it back. Then another agent is launched to get some other information or do something else, and then like they set up this like agentic workflow in that way. Gemini CLI does that. I'm pretty sure the newer agent frameworks are also doing it. I haven't had a chance to explore what is it called? I think it's called OpenClaw. Yeah, it's what was initially called CloudBot, and then Anthropic got angry about that, and then it was called Moltbot, I think. And then I think they changed that name because a bunch of crypto scammers started trying to make tokens out of it, and then they finally landed on OpenClaw. I think that's the same one that I'm thinking about. I believe so. I believe so. I hope I'm right. But yeah, yeah. This is dude. This tool is incredibly powerful. It is so powerful that NVIDIA has decided to add. NVIDIA has decided to create integration um, for OpenClaw. I don't know exactly in what way their integration helps. I'm gonna have to look that up because I don't even know the basics of OpenClaw itself to be able to tell you that, oh, um, this thing does so and so, so and so, it takes so and so action, and through the help of NVIDIA's integration, it can now do so and so extra thing. My knowledge about OpenClaw is limited to just this is an agentic framework. This is something that allows people to create an agentic workflow. And it's not, at least to my knowledge, because of the amount of people that have been able to adopt this, the amount of people who are, by the way, not programmers at all, who have been able to adopt this, my guess is this gives you an interface where you can sort of prompt everything and type out information and set up an agentic workflow. And also, I think whatever LLM is being used, or whatever model is being used for the agentic workflow, it itself will decide what agents it needs to create. You're probably creating like a main agent and giving it like an objective, and then it does its own thing. It creates like sub agents to do various tasks. Why was I talking about this? I remember I was mentioning that I need to explore OpenClaw. I haven't had the chance to explore it yet. I'm being 100% honest here. I don't really want to explore it all that much. Um, I might explore it at some point, but I'm more interested in exploring agentic framework libraries. So that's why I want to go through the um, Hugging Face Agents course, and I also want to go through the Hugging Face LLM course because LLMs are involved in this. But I don't want to use a pre-built program. I would much rather use a library that would let me set up an agentic workflow, and if I'm able to do it using Rust, that's even better. That's like a gold mine. And that actually reminds me that one of the multiple things that I need to do research on in Rust, once I've finished the basics, that is, at some point in time, one of the multiple other things that I want to look into is an actor framework, because this is something that I, even just as a general concept, I've never had the chance to explore this concept. The concept of setting up actors to do various tasks. You set up the actor, give it an objective, and then just let it complete its thing. My assumption is that it runs on a different thread. It finishes its thing, and there's a runtime that's tracking all of these actors, and then you can like query when so and so thing is done. You can probably also create like complex behavior to say that, okay, we have multiple actors, but then actor O2 is not going to execute until actor O1 has finished its job, and then you can create like dependencies in that way, or a chain of actors. There's a bunch of different like configurations that you can use. But once I came across Ractor, I actually came across Ractor through, what was it called? Auto Agent, I think. I think it was called Auto Agent. It's a agentic framework meant for LLMs, built in Rust, and it is built on top of Ractor. So that's what made me look into Ractor and how it works. And I didn't finish learning about Ractor because uh, I later found out that Ractor is built on top of Tokyo, and I realized that, oh yeah, I don't have my basic Tokyo knowledge. I mean, I have very basic knowledge, like very, very basic in the sense I can just spawn tasks and wait for them to finish, but that's about it. Doing more complex stuff where I have like multiple tasks that have been spawned, and maybe the tasks themselves are sending data back and forth to each other. So none of them ever really even touch main, as in touch the main thread. Stuff like that. I haven't gotten into it, and I think even the reason for that was that I didn't finish learning the basics. Because in there we were starting to use stuff like mutex and arc mutex, and that made me realize that okay, I haven't fully explored the concept of smart pointers. I did explore smart pointers a little bit in the past, and I got like very basic knowledge of it. I even created like a very simple tic tac toe terminal game. Um, and in that, I believe I used RefCell or RC, one of these two, and Box was also used to a certain extent. But I haven't had the chance to like explore it a whole lot, so I would definitely like to get into I would definitely like to get into smart pointers, which is actually our next topic. In I don't want to open up that conversation in Gemini CLI. It is loaded. Actually, no, it's not loaded. It's open currently, but if I tab into that tmux window, then it's gonna load. It's gonna start loading the conversation, and I don't know if that's gonna like crank up the CPU fan speed because the fans are already starting to make sound, which is okay because I'm probably not going to be streaming for too much longer. I think today's stream is mainly going to be a yapping stream about what all I want to do, what all projects I want to work on. There's definitely a whole lot of man. Shit is moving so fast. Shit is moving incredibly fast. Have to. I need to step things up, dude. I need to step things up and learn quicker. I feel like once I learn these basics of like ESP32 stuff, ESP32 no STD Rust stuff, I feel like that's gonna be a good starting point for me with electronics, and then I can start building my hobby projects and sort of get better, get more experience with this stuff after that. So I'm not gonna I, I'm I mean I'm still going to be in the learning phase, but like that learning phase is going to be a little different. So once this is done, um I mean it's not truly going to be done, but once I've done a fair bit of chapters from the book, which is the ESP32 Impel Rust book, once I've done a fair bit of chapters, I'm sure I will have explored a whole bunch of concepts. And fortunately, a bunch of the hardware that's required for various circuits, I have that hardware. So I have I believe LDRs are part of the thing. I have an LDR, I have a piezoelectric buzzer, I have as in the piezoelectric diaphragm, but I can use that as a buzzer kind of. It's kind of interesting how those things work because you can give them a pulse to create like a vibration kind of thing and create sound from it. You can give it a pulse to create to get sound from it, but at the same time, and this is like output from the microcontroller. At the same time, if you give it mechanical force, you can actually generate a pulse and send that back to the microcontroller. So that's something you actually need to be careful of with when you're connecting the thing directly to your microcontroller. And at some point, I would like to explore that. But yeah, we have piezoelectric. Why am I trying to guess? I can just look at the list here. Um, okay, so what all is in this list? So there's PWM. We have our simple fading LED. Um, we have the embassy thing. Then we have the buzzer. Here they're asking for a buzzer, but I only have piezoelectric diaphragm, so I'm just going to use that. There'll be like minor differences here and there. The code should be the same for the most part. The only thing that might be different is maybe um, the amount of pulses that I have to give. Maybe maybe the yeah maybe the amount of pulses I have to give might be a little different. It might be higher, it might be lower. I don't know. But yeah, I can use that as a buzzer. Voltage divider, we're just going to be studying it with either two resistors or with a potentiometer. Then I have the ultrasonic sensor. Um, that's actually an interesting one. Um, hold on. This so this is great for like distance sensing, at least from what I know, which is which is why it's great for like tracking what is in front. Actually, I shouldn't say distance. I think it's more for tracking objects in front. And you can determine the distance based on what is returned from whatever is bounced back. Based on that, you can determine what the resistance is. So yeah, resistance distance. Based on that, you can determine the distance. So in a way, yeah, it is. It's a decent distance sensor, but it's great for obstacle detection. Okay, then next, uh, PIR sensor. I'm excited to test this out because ever since I got this, like close to a decade ago at this point, I think. Well, let's say 8 years ago, 7, 8 years ago, 6, 7 years ago, 7, 8 years ago. Ever since I got this, I do remember having this. I just never managed to use the thing, and that's why I'm excited. Like even the ultrasonic sensor, I had one of these. I still ordered a couple because I know I'm going to be using it for robotics. But I did have one of the ultrasonic sensors, and this is called a PIR sensor. What is this used for exactly? Okay, it says we will use so-and-so PIR sensor module. It has an onboard pyroelectric sensor that helps to detect movement, and a dome-shaped Fresnel lens that helps to increase the range of detection. It can work with a power supply of 5 volts to 12 volts. Oh, 5 volts. So I'm going to need to plug V in into it, not 3.3 volts. Give me a second. I just remembered that I have to open up my chat. Yeah, okay. So I do have this sensor as well, this module, in fact, as well. And how all are we connecting the how all are we no how are we connecting all of these all of the connections in this? Oh, there's only three. Okay, so there's ground, there's digital out, and it says here 3 to 5 volt VDC power. Okay, so I'm guessing the way that this works is this is basically always putting out information. You're not really controlling too much else. You can like customize things on the board itself through these various jumpers, and I think there's these are not jumpers. These are trim parts. These are or something similar to trim parts. Uh, if we look here, let's go back. Yeah, I think this is what I was looking at, and these do look like trim parts. Like I can put a screwdriver in here and turn the thing, and there's an arrow that sort of gives you an idea of whether it's like um what direction it's supposed to be pointing in, because of which you get an idea of what's minimum and what's maximum. That's what I was trying to say. Then there's a set of jumpers here, and then the rest of it is whatever is required by this circuit. I also like that, yeah, you have some adjustments that you can make here. Um, delay slash time adjust and sensitivity slash or sensitivity adjust. Okay, so that's the PIR sensor. I have this sensor module, which is great. So we are able to do projects with this. By the way, if you guys want to do these kinds of projects, and you want to buy a kit that contains these kinds of parts, you can go on something like AliExpress. I would definitely recommend getting it off of AliExpress because um, you can get stuff super cheap there, like incredibly cheap. Of course, be careful of who you're buying from. Make sure that whoever you're buying from, they have they've sold an insane amount of the items or an insane amount of that item, and they also have a bunch of reviews. If possible, look for photo reviews. So reviews that contain a pic, a photograph, or more, multiple pics, because a lot of times when people receive the product, they take pics to show that, yeah, this is what it looks like. I've received the product, it's in good condition, and so on and so forth. And they post a review that way, and that actually helps because that has been one of the deciding factors for me when I was trying to buy stuff from various sellers. But yeah, what you can do is you can go onto AliExpress and um, type in, I don't know what, 12 in 1, 20 in 1. Just type electronic projects kit. Oh, Arduino projects kit. You can look up something similar to that, and I'm sure the AliExpress website itself will give you recommendations for stuff to search for. And once you start searching for this stuff, then the website itself will recommend some similar products to you. Basically, these are kits that don't contain the microcontroller itself, but they contain. Did I say control? I don't know if I said control or contain, but I meant contain. They don't contain the microcontroller itself. They contain all various modules and parts, modules and components and peripherals, wires and stuff that you might need to to set up various types of projects. So they give you multiple different types of modules. Like you might have an RF related module. You might have um, an RFID related module. You For the RF module, you might also have they've created like a, what do you call it? There's a very famous frequency. I think it's 433 or 443 megahertz. Apparently, this is the frequency at which a lot of your cheap electronics operate, including like toys and stuff. Like if you look at RC cars, cheap RC cars, I don't know about the more expensive ones, but the cheap RC cars, a lot of them tend to operate on this frequency as well, which is kind of interesting because I've had situations where I opened up, and this only seemed to be an issue once I opened up the RC car. I'd purposely bought a couple of cheap RC cars with the intent of hacking them. Um, and I'm probably going to be buying more because that's going to be so much cheaper than trying to buy something robotics related online. Though the robotics related stuff is specifically robotics related, and so the development steps that'll be involved, the development experience that you're going to get of working with a robotics kit is going to be different when you're working with a robotics kit. But in my case, my experience is going to be of building or hacking an existing circuit using a microcontroller, specifically an ESP32. And yeah, what was I saying? Oh yeah, I was going to talk about how there's like ghost frequencies that get read by the antenna of the car, because I've had situations where the car just started to move front and back randomly as long as the switch was on. So it was picking up the signals from somewhere. I just couldn't tell from where. And it turns out some of these ghost signals can actually make it through like walls and stuff, and that's why sometimes if it's coming from maybe a flat nearby or something, then it's going to be picked up. Or maybe there's just some other cheap electronics that's putting out a similar signal to what the RC car is expecting. I should look into what that would look like. Like I know from a higher level that okay, yeah, it's a signal that this thing is expecting, and it knows to uh, respond to a very specific to a very specific signal, which is basically a package of data that's coming on this frequency. But what does that data look like? I don't know that. So that would be interesting to look into. Okay, okay. Anyways, like I was saying, you. Oh yeah, yeah. You have. I was talking about like the RF module. So with the RF module, you also get. Actually, I have the kit with me, but like I would have to go and take it out from wherever it is packed in right now, and then I would have to open the thing up, and I don't want to do all that right now. So I'm just describing it. But you get a fair bit of different components, different modules and stuff to work on. First of all, work on simpler circuits that use those individual modules, and then you can work on something more complex that involves multiple modules working together. Oh, additionally, so they give you a bunch of different modules and different ways to work with them. So, like, okay, you have the for HID, human interface device, I believe it is. Basically, they give you like a keypad, and this keypad you can interface with this to get data when a button is pressed. I never actually tested that out. I should test that one out as well. Then there's also an NFC tag reader kind of thing. And then I was talking about the RFID, no, the RF specifically, RF module with the 400 and something megahertz. I think it's 433, or it could be 443, one of the two. But yeah, with that module, you also get a remote that operates on that frequency. It has circuitry inside. It has buttons. It basically looks like a simple garage door opener kind of remote, and it has a long antenna as well that you can like, um, you know, pull out. You can expand and shrink it and stuff. Sorry, zoned out. Okay. What else does it have? It definitely, yeah, it has the LCD module. It has the LCD display. You do have to solder wires or header pins onto it. I think because of its weight, it didn't have um the header pins on it because the thing does carry a bit of weight to it. So whenever I do solder it, I'm gonna have to see how I want to go about um setting the thing up in a way that I can like use it because it does carry a bit of weight to it. And so if I try to put it on, if I try to solder header pins on and then I place the thing on the breadboard, I'll need to make sure that um, the the display itself is sitting on the breadboard and hanging off of um, it's not hanging off of the header pins in any way. I don't know how to explain that, but like I need to make sure that that doesn't happen because eventually that's going to damage both the pins and the breadboard things. The breadboard like holes. What else is there? There's more stuff. There's a servo motor in there. I believe that's meant to connect directly to the microcontroller. It's worth mentioning that these are projects that are meant to be done with Arduino Uno, which works on the 5 volt in the five volt range. I don't know what the max current um, supported there is, but like it's working in the 5 volt range, while the ESP32 usually works in the 3.3 volt range. Give me a second here. What else is there? There are a couple of other things. I think maybe there was something lighting related. I can't remember. Oh, there was a yeah, I just remembered this. There was a matrix, an LED matrix driver module. So like it's an LED matrix that is on the module board. So like the entire it's the entire driver module with the LED matrix. So you don't need to worry too much about like, um giving it the right amount of resistors and stuff like that. You just need to talk to the LED driver itself. So that should be an interesting project to work on. That is probably not included here, but yeah, uh, that is part of that kit. So that's why I'm saying like, you guys can get cheaper. You can get like nice cheap kits containing these multiple different modules. It's going to be one of each. It's not going to be multiple, but like it'll allow you to explore doing projects in ESP32 using various modules. And oh yeah, they also give you, I think, one breadboard comes with the kit. There's a couple of discrete components that come with it, resistors, capacitors. I think LEDs come with it as well. Um, there's also jumpers because there's a breadboard, and maybe a couple of things. It's a pretty decent. It's a neat kit if you're um, budget constrained and you want to get into microcontrollers and doing microcontroller projects and stuff. It's great. That project kit is great. Okay, so after PIR we have the servo motor, and I still need to do research on this because I'm not entirely sure how safe it is to directly control the servo from my ESP32. So I'm gonna have to look into it. Like here it's being controlled. You know what? This is a good point. Actually, okay, this might be putting out what maybe PWM. I'm not sure. Yeah, I think it's PWM. No. Okay, with a servo, you are usually supposed to give it commands to stay at a certain thing. How are you giving it commands though? Are you giving it commands, or are you sending it PWM signals to describe what is meant to be between, 0 and whatever the max rotation of the motor is? Because I believe, okay, changing servo motor's position based on PWM. Okay, okay. We're probably going to be using PWM. So yeah, I need to do some research on this and see how safe or unsafe it is to um, plug the thing directly into the ESP32. I did notice that we are giving it 5 volts. And so like we are connecting it to V in rather than 3.3. So 3.3 is what the entire microcontroller is operating at. That's the range, that's the voltage range that the microcontroller is operating at. The the dev board itself takes in takes in 5 volts because you connect either a phone charger or a USB port or something. Definitely don't have this thing connected to a I need to remember this. That definitely shouldn't have um, this thing connected to a USB port when I'm trying to control a servo with it. I should do some research on like what the current is going to be, what the current draw is going to be like. But yeah, then after servo, we're going to be exploring ADC and then LDR. So I have an LDR already. I actually have the thing hooked up right now. I can block out the light to the LDR and you'll notice the red LED. You'll notice the red LED dimming and also lighting back up when I remove my hand from the LDR. Give me a second. Let me just, yeah. So now I'm going to put my hand there and block out the light, and you'll notice the LED dimming, and and then I'll remove my hand and it's going to become light again. Yeah. So, where was I? Okay, yeah. LDR. So that's going to be the LDR. That's a determined, light dependent. That's the word. Okay, I keep confusing determined and dependent. Light dependent resistor. That we can connect it directly into the ESP32 because it's basically a resistor. Then we're going to go into Wi-Fi, which is already on the board, and we can do some interesting stuff with that as well. Then I2C, which is a communication protocol. Okay, I was about to say so is ADC, but no, ADC is not. Um, so is SPI, which comes later on. Then we have the OLED display. I don't have this, so I don't think I'll be able to do this specific thing, but it's really interesting that we can communicate with this display using just these four pins, and out of that, two of the pins um, are VCC and ground. So two of them are power pins, and then there's only two being used for communication. I believe SCL is a clock, and then SDA is where you send the data on. I think so. I don't remember, but yeah. I don't have this specific one. However, I do have, I don't know where the other one comes in. LCD comes in later on, doesn't it? That is this one. Yes, I have exactly this. And this is what I was talking about. It's a bulky kind of module, and you connect your pins here. I don't think I have this. Do I have this? I don't think I do. Because I have this thing. I don't have the headers soldered on. I'm gonna need to solder the headers. This one does have the headers soldered. Um, and then the entire thing itself is kind of bulky, so I need to find a good way to kind of add padding at the bottom or like close the gap between where the module is sitting and the surface that it's sitting on or that it's supposed to be sitting on. But yeah, we can explore this as well. The good news is I also have a level shifter. It's mentioning here that we're probably going to be using a level shifter. GPIO pins are 3.6V tolerant, which means they are not safe. Oh, I didn't take that into account. Holy shit, I did not consider that. Okay, I think yeah, so I was a little late to start the stream today. I do need to end the stream right now. Yeah, that's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.